Programming languages. Programming languages are the foundational tools of the digital age, enabling us to develop software, create applications, and build websites that drive modern technology. Each language has its own syntax and unique features, catering to different kinds of projects and industries. From the elegance of Python's simplicity to the robustness of Java's enterprise capabilities, the diverse landscape of programming languages offers powerful solutions to a wide array of challenges. Whether you're developing web applications with JavaScript, delving into data science with R, or building high-performance software with C++, understanding these languages is essential for harnessing the full potential of technology. Let's dive into one of the most versatile and beginner-friendly programming languages, Python. Python is a high-level, interpreted programming language known for its readability and simplicity. It emphasizes code readability with its use of significant indentation, which makes it easy to learn and use. Python supports multiple programming paradigms, including procedural, object-oriented, and functional programming. It's widely used in various domains, such as web development, data analysis, artificial intelligence, scientific computing, and automation, thanks to its extensive standard library and active community. Let's dive into the mechanics of Python with some clear examples. Basics of Python. Python is known for its readability and simplicity, using indentation to define code blocks. Here's an example of a basic Python script. In this script, print hello world is a function call that outputs the string hello world to the console. Variables and data types. Python handles variables dynamically, meaning you don't need to declare a variable type explicitly. Control structures. Python uses if-else statements for conditional logic. Loops. Python supports for loops and while loops. Functions. Functions in Python are defined using the def keyword. Lists and dictionaries. Python provides powerful data structures like lists and dictionaries. Object-oriented programming, OOP. Python supports OOP principles such as classes and objects. Libraries and frameworks. Python's ecosystem includes many libraries and frameworks. For example, NumPy for numerical computing. Python's simplicity and versatility make it a powerful language for a wide range of applications, from web development to data science. Now that we've explored Python's versatility and simplicity, let's turn our attention to JavaScript, the powerhouse behind interactive and dynamic web pages. JavaScript is a dynamic programming language primarily used for enhancing web pages, making them interactive and dynamic. Let's break down how it works with examples. Client-side scripting. JavaScript runs directly in the web browser. When you visit a web page, the browser downloads the HTML, CSS, and JavaScript files. The JavaScript code is then executed on the client's machine. Example, basic syntax. Here, alert, hello, world, shows a pop-up message, and console.log outputs text to the browser's console. Manipulating the DOM, document object model. JavaScript can modify HTML content and CSS styles dynamically. This script changes the content and color of an HTML element with the ID myElement. Event handling. JavaScript can respond to user interactions like clicks, key presses, and mouse movements. When the button with the ID myButton is clicked, an alert box will pop up. Functions. Functions in JavaScript are blocks of code designed to perform particular tasks. The greet function takes a name as an argument and returns a greeting message. Asynchronous programming. JavaScript supports asynchronous operations like fetching data from a server without reloading the page. This script fetches data from a server and logs it to the console, handling success and error responses. Object-oriented programming, OOP. JavaScript supports OOP, allowing you to create objects and classes. The person class defines properties and methods that can be used to create and interact with objects. JavaScript frameworks and libraries. JavaScript has a rich ecosystem of frameworks and libraries like React, Angular, and Vue.js, which simplify complex tasks and enhance productivity. JavaScript's ability to manipulate the DOM, handle events, and execute asynchronously makes it indispensable for modern web development. It brings web pages to life, enabling interactive and responsive user experiences. Having explored JavaScript's role in creating dynamic and interactive web experiences, let's shift gears to Java, a powerful language renowned for its portability and robustness in building a wide range of applications, from mobile to enterprise systems. Java is a high-level, object-oriented programming language designed for portability and efficiency. Let's dive into its core concepts and mechanisms with examples. Object-oriented programming, OOP. Java is fundamentally object-oriented, meaning it relies on objects to represent data and methods to manipulate that data. Example: basic syntax. In this example, public class hello world defines a class, and public static void main string args is the entry point of the program. System.out.println hello world prints hello world to the console. Variables and data types. Java has strong type checking at compile time, requiring explicit declaration of variable types. Control structures. Java uses traditional control structures like if-else and switch case for decision making. Loops. Java supports for loops, while loops, and enhanced for loops for arrays. Methods. Methods in Java define reusable blocks of code that perform specific tasks. The greet method takes a name as an argument and returns a greeting message. Classes and objects. Java's OOP principles are showcased through classes and objects. In this example, person is a class with properties, name, age, and methods. Introduce. An instance of the class, person, is created and its method is called. Inheritance. Java allows classes to inherit properties and methods from other classes. The dog class inherits the eat method from the animal class and adds its own method, bark. Exception handling. Java handles errors through exceptions, ensuring robust and error-free code. The try-catch finally blocks are used to handle exceptions and execute cleanup code. Java Virtual Machine, JVM. Java's write once, run anywhere capability is achieved through the JVM. The Java source code, .java files, is compiled into bytecode, .class files, by the Java compiler. This bytecode can be executed on any platform with a JVM, ensuring portability. Java's combination of OOP principles, robust type checking, and platform independence makes it a powerful language for building a wide range of applications, from mobile apps to large-scale enterprise systems. Having understood the robustness and portability of Java, let's delve into C++, a language that combines the power of low-level memory manipulation with high-level object-oriented features, making it indispensable for systems programming and game development. C++ is a high-performance programming language that builds on the foundation of C by adding object-oriented features. It's widely used in systems programming, game development, and applications requiring real-time performance. Here's how it works. Object-oriented programming, OOP. C++ supports classes and objects, enabling encapsulation, inheritance, and polymorphism. Example: basic syntax. This program includes the IOStream library, which provides input and output facilities. std::count is used to print hello world to the console. Variables and data types. C++ requires explicit declaration of variable types. Control structures. C++ uses if-else statements and switch case for decision-making. Loops. C++ supports for loops, while loops, and do-while loops. Functions. Functions in C++ define reusable blocks of code that perform specific tasks. The add function takes two integers and returns their sum. Classes and objects. C++/OOP principles are showcased through classes and objects. In this example, person is a class with properties, name, age, and methods. Introduce. An instance of the class, person, is created and its method is called. Inheritance. C++ allows classes to inherit properties and methods from other classes. The dog class inherits the eat method from the animal class and adds its own method, bark. Templates. C++ supports generic programming through templates, allowing the creation of functions and classes that operate with any data type. The add function template works with any data type, whether integers or doubles. Memory management. C++ allows manual control over memory allocation and deallocation using new and delete. This script allocates an integer in memory, assigns a value, prints it, and then deallocates the memory. C++'s powerful features, like OOP, templates, and direct memory management, make it ideal for high-performance applications and systems programming. Building on the power and complexity of C++, let's now turn to C#, a modern and versatile language developed by Microsoft, known for its efficiency and integration with the .NET framework, widely used for Windows applications and game development. C# is a modern, object-oriented programming language developed by Microsoft. It's particularly known for its strong integration with the .NET framework, making it powerful for building Windows applications, web services, and games with Unity. Let's explore how C# works with some detailed examples. Object-oriented programming, OOP. Like Java and C++, C# is deeply rooted in OOP principles, which include encapsulation, inheritance, and polymorphism. Example: basic syntax. In this example, using system imports the system namespace, and console.writeLine, hello, world, prints hello, world, to the console. Variables and data types. C# is strongly typed, meaning every variable must have a declared type. Control structures. C# uses traditional control structures like if-else and switch case for decision making. Loops. C# supports for loops, while loops, and for-each loops for iterating over collections. Methods. Methods in C# define reusable blocks of code that perform specific tasks. The greet method takes a name as an argument and returns a greeting message. Classes and objects. C#'s OOP principles are showcased through classes and objects. In this example, person is a class with properties, name, age, and methods, introduce. An instance of the class, person, is created and its method is called. Inheritance. C# allows classes to inherit properties and methods from other classes. The dog class inherits the eat method from the animal class and adds its own method, bark. Properties and indexes. Properties in C# provide a flexible mechanism to read, write, or compute the values of private fields. Here, radius is a property with a getter and setter, and area is a read-only property. Exception handling. C# handles errors through exceptions, ensuring robust and error-free code. The try-catch-finally blocks are used to handle exceptions and execute cleanup code. Integration with .NET framework. C# is tightly integrated with the .NET framework, providing access to a rich library of pre-built functionalities for tasks like file I/O, database access, and web services. C# combines the robustness of Java with the power and flexibility of C++, making it an excellent choice for modern software development, especially in the context of Microsoft technologies. With a strong grasp of C# and its seamless integration with the .NET framework, let's now explore Ruby, renowned for its elegant syntax and the power behind the Ruby on Rails web framework. Ruby is a dynamic, open-source programming language known for its simplicity and productivity. Its elegant syntax is designed to be easy to read and write. Ruby is often associated with the Rails framework, which simplifies web application development. Let's dive into the mechanics of Ruby with examples. Object-oriented programming, OOP. Ruby is purely object-oriented, meaning everything in Ruby is an object, including numbers and functions. Example: basic syntax. In this script, puts hello, world, outputs the string hello, world, to the console. Variables and data types. Ruby handles variables dynamically, meaning you don't need to declare a variable type explicitly. Control structures. Ruby uses if-else statements and case-when for conditional logic. Loops. Ruby supports for loops, while loops, and times loops. Methods. Methods in Ruby define reusable blocks of code that perform specific tasks. The greet method takes a name as an argument and returns a greeting message. Classes and objects. Ruby's OOP principles are showcased through classes and objects. In this example, person is a class with properties, name, age, and methods, introduce. An instance of the class, person, is created, and its method is called. Blocks and iterators. Ruby's blocks and iterators provide a convenient way to handle collections. Exception handling. Ruby handles errors through exceptions, ensuring robust and error-free code. The begin rescue ensure blocks are used to handle exceptions and execute cleanup code. Ruby on Rails. Ruby is often associated with the Ruby on Rails framework, which simplifies web application development by following the convention over configuration principle. Ruby's clear and readable syntax, along with powerful features like blocks and iterators, make it a joy to work with, especially for web development with Rails. With Ruby's elegant syntax and the power of Rails under our belts, let's move on to PHP, a widely used server-side scripting language that powers a significant portion of the web. PHP, Hypertext Preprocessor, is a widely used open-source server-side scripting language designed for web development. It's particularly known for its capability to embed directly into HTML, making it a powerful tool for creating dynamic web pages. Let's dive into how PHP works with detailed examples. Embedding in HTML. PHP can be embedded directly within HTML code, enabling dynamic content generation. In this example, PHP echoing hello, world is a PHP tag that outputs hello, world within an HTML h1 tag. Variables and data types. PHP is dynamically typed, so variable types do not need to be declared explicitly. Control structures. PHP uses if-else statements and switch case for decision-making. Loops. PHP supports for loops, while loops, and for-each loops for iterating over arrays. Functions. Functions in PHP define reusable blocks of code that perform specific tasks. The greet function takes a name as an argument and returns a greeting message. Arrays. PHP provides flexible and powerful arrays. Object-oriented programming, OOP. PHP supports OOP, enabling encapsulation, inheritance, and polymorphism. In this example, person is a class with properties, name, age, and a method, introduce. An instance of the class, person, is created and its method is called. Form handling. PHP excels in handling form data submitted via HTTP POST and GET methods. This form collects a user's name and greets them upon submission. Database interaction. PHP can interact with databases using extensions like PDO, PHP Data Objects. This script connects to a MySQL database, fetches data from the students table, and displays it. PHP's ability to embed in HTML, handle forms, and interact with databases makes it a powerful tool for web development, driving dynamic websites and applications across the internet. Having explored the dynamic capabilities of PHP for server-side scripting and web development, let's now delve into Swift, Apple's powerful and intuitive language designed for developing iOS and macOS applications. Swift is a powerful and intuitive programming language created by Apple for building iOS, macOS, watchOS, and tvOS applications. It's designed to be easy to use while being highly performant. Let's explore its core features and how it works with detailed examples. Modern syntax. Swift syntax is clean and expressive, making it easy to write and read. Example, basic syntax. This simple script prints hello, world, to the console. Variables and data types. Swift uses var for variables that can change and let for constants. It also has strong type inference but allows explicit type declarations. Control structures. Swift uses traditional control structures like if-else and switch case for decision-making. Loops. Swift supports for loops, while loops, and repeat while loops. Functions. Functions in Swift define reusable blocks of code that perform specific tasks. The greet function takes a name as an argument and returns a greeting message. Optionals. Swift introduces optionals to handle the absence of a value. Classes and objects. Swift's OOP principles are showcased through classes and objects. In this example, person is a class with properties, name, age, and a method, introduce. An instance of the class, person, is created, and its method is called. Structs. Swift also supports structures, structs, which are similar to classes but are value types. Error handling. Swift has robust error handling using do-catch blocks. The fetchData function throws an error if the URL is invalid, which is then caught in the do-catch block. Swift UI. Swift is also used with Swift UI, a framework for building user interfaces across all Apple platforms. This Swift UI view displays "Hello, World" with some padding. Swift's modern syntax, safety features, and performance make it a powerful language for developing applications across the entire Apple ecosystem. Its combination of readability and expressive power has made it a popular choice among developers. Having explored the sleek and powerful capabilities of Swift for developing Apple ecosystem applications, let's now turn our attention to SQL, the go-to language for managing and querying relational databases. SQL, Structured Query Language, is a standardized programming language used for managing and manipulating relational databases. It's the go-to tool for querying and editing data stored in a database. Let's explore its core features and operations with examples. Database structure. Relational databases store data in tables, which consist of rows and columns. Each table has a unique name, and each column has a specific data type. Example: creating a table. This SQL command creates a table named employees with columns for employee details. Inserting data. To add records to a table, you use the insert into statement. This command inserts a new record into the employees table. Querying data. The select statement retrieves data from one or more tables. This query retrieves the first name, last name, and position of employees older than 25. Updating data. To modify existing records, you use the update statement. This command updates the salary of the employee with ID 1. Deleting data. The delete statement removes records from a table. This command deletes the record of the employee with ID 1. Joining tables. SQL allows you to combine data from multiple tables using joins. The most common type is the inner join. This query retrieves the first name, last name, and department name of employees, combining data from the employees and departments tables. Aggregate functions. SQL provides functions to perform calculations on data, such as count, sum, average, minute, and max. This query calculates the average salary of all employees. Grouping data. The group by statement groups rows that have the same values in specified columns into summary rows. This query counts the number of employees in each position. Ordering data. The order by statement sorts the result set of a query by one or more columns. This query retrieves employee details sorted by salary in descending order. Creating indexes. Indexes improve the speed of data retrieval operations on a table. This command creates an index on the last name column of the employees table. SQL's powerful querying capabilities and straightforward syntax make it essential for managing and manipulating relational databases, enabling efficient data retrieval, updates, and analysis. Having delved into the powerful querying capabilities of SQL for managing and manipulating relational databases, let's now shift our focus to R, a language specifically tailored for statistical analysis and data visualization. R is a programming language and software environment specifically designed for statistical computing and graphics. It's widely used among statisticians, data miners, and data scientists for analyzing and visualizing data. Let's explore how R works with detailed examples. Interactive environment. R is typically used in an interactive environment where you can type commands and see immediate results. This makes it highly conducive to exploratory data analyses. Example: basic syntax. In this example, print "Hello, World" outputs the string "Hello, World" to the console. Variables and data types. R dynamically assigns data types to variables without explicit declaration. Vectors. R operates on vectors, which are sequences of data elements of the same type. Data frames. Data frames are tabular data structures in R, similar to spreadsheets or SQL tables. Control structures. R supports if-else statements and loops for control flow. Functions. Functions in R define reusable blocks of code that perform specific tasks. The greet function takes a name as an argument and returns a greeting message using paste to concatenate strings. Statistical analysis. R provides a wide range of built-in functions for statistical analysis. Data visualization. R excels at creating high-quality visualizations using packages like Golot2. This code creates a scatter plot of the MTCAR's dataset, visualizing the relationship between weight and miles per gallon. Packages. RS functionality can be extended through packages. CRIN, Comprehensive R Archive Network, hosts thousands of packages for various purposes. RS strength lies in its statistical capabilities and the ease with which it can handle and visualize data. Its extensive package ecosystem and interactive environment make it a favorite tool among data scientists and statisticians. Programming languages form the backbone of the technology we use daily, each offering unique strengths and capabilities for various applications. From Python's simplicity and versatility, JavaScript's interactivity on the web, Java's robustness in enterprise systems, C++'s performance in game development, C#'s efficiency with the .NET framework, Ruby's elegant syntax, PHP's power in web development, Swift's performance in iOS and macOS apps, SQL's capability in managing relational databases, to RS prowess in statistical analysis and data visualization, understanding these languages equips us with the tools to innovate and create solutions that drive our digital world forward. Embracing the diversity of programming languages opens up endless possibilities in the realm of software development and data analysis. Please remember to subscribe, like the video, and share it with your friends. Your support is greatly appreciated.